Fisheries stock assessments generate our understanding of how many fish are in a stock in the sea, so that we can predict future harvest rates that are sustainable. To perform a stock assessment, we first need to understand the population dynamics within the fish stock, so things like reproduction and mortality rates. This is achieved through a variety of fisheries data collection. Then, analysing this data, scientists build a picture of the stock using a mathematical model. This can predict the future of the stock under varying conditions and harvest rates. However, collecting data on fish stocks is often difficult. Fish live underwater, it's dark, and they're not easy to observe. Also, fish distribution is patchy, as they move around continually, looking for food and places to spawn. So, to try and get the full picture, some data is gathered directly from the fishing industry, such as how much is being caught and where, and this is called fisheries-dependent data. Data is also gathered using research vessels, and this is called fisheries-independent data, and includes biological information on the relationship between size and age of individuals and reproduction rates. Observational data collected from fisheries and research is used to help scientists understand how fish stocks have changed over time, and can be input into models which pull together various sources of observational data and use scientific and mathematical theory to understand the past and predict the future. But there will always be a level of uncertainty in these predictions. Other widely used models are those used by weather forecasters to predict if it'll be a sunny or rainy day tomorrow or next week, using their knowledge of the physics of the air coupled with a variety of weather observations. But even the best models can't predict the weather with 100% accuracy, and the same applies with fisheries stock assessments. So, scientists will usually say they're 80 or 90% confident, but there will always be some error when predicting the future. Scientists will use a percentage confidence level, communicate this in their models, and consider accuracy and precision as important dimensions of a prediction. So for fishery stock assessment models, for example, if there is uncertainty about reports of historical catch data, this will introduce uncertainty when projecting into the future. Fisheries models are used to help describe the relationship between different observations. For example, water temperature and other oceanographic variables, how many fish are being caught or dying naturally, how successfully is the population reproducing, and more. The number of different observations and how they might vary are extremely extensive. Models also help to understand unknown variables or what-if questions, such as how many sexually mature fish are there within the stock that are able to reproduce and replenish the stock in the future? And how will this change if the total catch increases or decreases? In summary, fish stocks are monitored, assessed, and future projections are made using real data inputted into models that consider a level of uncertainty to give an overall view of the stock and predict possible future scenarios. This can then be used to inform fisheries management and work with the industry to maintain sustainable fisheries.